In this part of Chapter 12, we're going to learn how to draw Lewis structures. So we're going to start by looking at the difference between a molecular formula, which we've talked about in a previous chapter, and a Lewis structure. So molecular formulas tell us which atoms or elements are present and how many you have of each. So this is an example of a molecular formula. And so we could see here we have 1 carbon, 2 hydrogens, and 1 oxygen in our molecule. Now, what a molecular formula does not tell us is how the atoms are bonded together. So Lewis structures are a way that we draw the bonding for a molecule. And so let's look at this Lewis structure here. So that is for the CH2O. This is actually formaldehyde. And let's see what each of these things represent. So in a previous chapter, we talked about a covalent bond. And here, this double line represents a double bond. Each line represents a shared pair of electrons. So double bonds share 4 electrons. The hydrogens, both of them, have a single line, and that single line represents a single bond, and a single bond shares 2 electrons. And then we also have oxygen, which has 2 pairs of these dots here, and these dots are electrons that are not involved in bonding, but they are present. They can be called a lone pair, or another name for lone pair is a non-bonding pair. The other language that I will use quite a bit, because I need to think about it for every single Lewis structure, is what we call the atom in the middle. So the atom in the middle is called the central atom. And the outside atoms could just be called the outside atoms, but sometimes they are called atoms in the periphery. And the periphery just means the outside. It just means the ones that are on the outside of the central atom. So oxygen and both hydrogens would be atoms on the periphery. Okay, so if you see that word, that's just what it means on the outside. And you might have already known that, but you know me, I don't want us to pass by words that not everybody understands. Okay, so let's think about let's see the steps to draw a Lewis structure from a molecular formula, and then we'll do several examples. And then in other videos, you will learn different things that we can account for or predict based on the Lewis structures. So there's a couple things that we have to think about when we're talking about Lewis structures. One thing is we are going to have to count up electrons, but we only want the valence electrons. And to count the valence electrons, we are going to use the group numbers on the periodic table. So we won't have to draw electron configurations or anything. We'll just use the periodic table to find them. Okay. The other thing is we're going to be following the octet rule here. And so our main group elements, so we're talking about the elements that are in the tall columns on the periodic table, the ones that have an A next to their group number, we're going to give them all 8 electrons. Okay, so that's what the octet rule. Remember, the octet rule said that atoms will gain, lose, or share electrons to have a noble gas configuration. So the gaining and losing is part of the transfer in the ionic bond, but the sharing part, that's covalent bonds. And so they also want to look like the electron configuration of a noble gas, which means have 8 electrons. Now there is an exception here, and that is hydrogen, because hydrogen cannot have 8 electrons. It only has a 1s orbital, so it can only have 2, and so it's an important thing, and I'm going to put some exclamation marks here, and that is we're going to get the number 8 in our mind, but when it comes to hydrogen, it can only have a single bond. Because it can only have 2 electrons. Okay, so no non-bonding pairs on hydrogen, no double or triple bonds on hydrogen. Hydrogen, like when I see it and I have to use it on a Lewis structure, I get very happy because I know it just has a single bond, like there's nothing else it can do. All right, so let's get into it. So here are the steps for a Lewis structure. And so let's take a look, and I'm going to have a different color arrow for each step because maybe that will help us as we learn to see how I'm adding to it. So let's start with a very simple one. It's CH4. Okay, so that's going to be our molecular formula, and that's what you'll be given is a molecular formula. So now let's look at the steps. So step 1, and I'll use a purple pen, says arrange the atoms next to each other that you think are bonded together. Place halogens on the periphery, there's that word, since it can, halogens and hydrogen, since on the periphery, since they can only form one bond. Okay, a single bond specifically. Now, what we need to determine here is the central atom. That's the first step. So in general, the first atom in the molecular formula is going to be the central atom. Now, there are more complicated Lewis structures than what we will be doing, but for our introductory class, we're going to be using formulas that have one central atom. The cool thing about it all is if you get really good at doing, just these Lewis structures, it's not a hard stretch to have something that maybe has 2 atoms in a row instead of just one central atom. So we want to really get good at this so we can add to it in the future. So the first element, back to this one, is the central atom. If hydrogen is the first atom, hydrogen will not be the central atom because it is can only have a single bond, and so it can't be in the middle. If hydrogen is the first atom in the formula you're given, go to the next element, and that's the one that's going to be the central atom. All right, so they want us to kind of make what they call a skeletal structure. We're going to put 1 in the middle. I'm going to put carbon, and then everything else in the molecular formula is going to go around the central atom. Now, how you place these on the outside of the central atom, there's not a specific rule. I tend to do everything in 90 degree or 180 degree when I'm drawing Lewis structures, simply because it kind of keeps everything apart from each other. But if you made them at different angles, it wouldn't matter. Lewis structures show us the bonding. They can be used, and we will use them to help predict shape, but the Lewis structure does not have to be drawn in a specific angles of their bond have their bonds drawn in specific angles. Okay, so back to the steps. That's the first step, what I just did. I took my molecular formula, chose the central atom as the first element, and wrote everything around it. So then the next step, step 2, says count your valence electrons. And I call this a magic number because this is how many electrons we have to use. And this number can range anywhere from 8 up into the 30s, maybe even 40s. I don't know, it can range. It just depends on the elements you're talking about. All right, so let's see, here's carbon, and it's in group 4. Now, I can write on the top what the numbers are. If you have a periodic table, get it out so you can see. But carbon is in 4A. So let's see, let's add up our valence electrons. So it would be, I can't spell there. Okay. All right, so there's one carbon atom, and it has 4 electrons. And then hydrogen, there are 4 hydrogen atoms in my formula, and hydrogen is over here, it has 1. Now, you don't have to draw a table like this. You do have to have an organized way to make sure you're counting up all of the valence electrons in your particular molecular formula. So this is the most organized way for me, but you just have to be able to count them all up. I encourage you to, if you don't have a table like this, at least write down how many valence electrons that you are using, especially like on an exam, so I can determine if your structure's not right, maybe where it went wrong, and if I can give you some partial credit for your thinking. So that's step 2. That's it. And now let's see, the big step is, where am I going to put these electrons? So that's step 3. So we have to take those 8 electrons, and it's like a puzzle. Sometimes it's harder than others, but we're going to put them around our atoms. So the first thing I always do is I place a single bond between the atoms, connecting them to the center. So a single bond is just a line, each representing 2 electrons, and I just connect all my periphery atoms to the center with a single bond. So that's always the first step I do. Then the second part of that, it says, and I'm just getting a different color highlighter. It says, use all remaining electrons to fill the octets with lone pairs. And here's a super important idea. You begin with the atoms on the periphery. So if you have extra electrons, you always place them on the outside first. That is because the outside atoms are never the exceptions. Lewis structures have exceptions to the octet rule. They can have fewer than 8 or more than 8 in the central atom. And so you always start with the outside, make sure they have 8, and then you deal with the center atom. Now in our class, we're going to be using Lewis structures where the central atom follows the octet. If you follow the outline of how you place the electrons onto your Lewis structure that I am teaching you, when you get to a point in chemistry where you have to tackle the exceptions, this plan leads you right into it. So it's just a matter of how you think about it at the end, and it would lead it right to it. So there's something that's actually quite nice about the steps that I'm laying out for you. I did not create them, and I know the other faculty at the school and at least one of them that teaches the next level uses this same process, so it can be helpful. So let me go back to this step. I placed my single bonds. Now I'm going to count how many electrons that took to see if I have anything left over. Like I've used some, so I've got to see if there's any left over. So I count what I put, 2, 4, 6, 8. So each single line is 2 electrons. So again, that's 2, 4, 6, 8. So I used 8 electrons connecting single bonds. So then if I say minus 8, because that's what I used, do you see that I have 0 electrons remaining? And so when this says up here, use all remaining, I don't have any. So at this point, I'm either done or I'm not. And this case, I'm going to be done, but I'll show you other cases when we wouldn't be done. How do I know if I'm done or I'm not? I go back to what I drew, and I make sure everybody has their octet, which means hydrogen all has 2, and anything other than hydrogen is surrounded by 8. So when I look at my hydrogens, they all have single bonds, so they all see 2 electrons. So they would be satisfied or happy. I like to call them happy. And then I look at my carbon, and carbon has 2, 4, 6, 8 electrons, which would be what everybody wants in the main group, 8. And so carbon is also satisfied or happy. And so this is the finished answer. So that is my Lewis structure for the CH4. So you can see some of these are quite simple when we when it's like this. So let's try another one and see. And then I'm going to add a little to it. So let's look at, okay, I've got one. So let's say I have NCl3. Okay, so here's the steps. First step is to draw the atoms how they're arranged. So we're going to take the first atom as the central atom. I'm going to place it in the middle, and I'm going to place the 3 chlorines around the outside. Now, if you place the chlorine on the top but not on the bottom, or you don't put in, doesn't matter as long as you have nitrogen in the middle and the chlorines are around it. There's only 3. The next step would be to add up the valence electrons. That's how I know how many electrons I'm going to use. So nitrogen, so the valence electrons, I'm just going to write it over here. So I have nitrogen, it's in group 5A, so I have 1 nitrogen in my formula, and it has 5 electrons. And then chlorine is in 7A, but I have 3 chlorine. So that is 21 electrons. So that is 26 electrons total. Okay, that's what I have to work with to make my Lewis structure. It's the magic number, 26. Now, as a general rule for our class, there will be no odd numbers. If you get an odd number, you go back and check what's going on. So that's one general rule. I had another general rule, but it left me. Okay, that's my general rule right now. No odd numbers. You can have odd numbers, but ours will not have odd numbers. Okay, it's called a free radical when you have that odd number. All right, so the next step is take the 26. We're going to place single bonds to the outside, from the periphery to the inside. So now I need to see, that's all the bonds I have. So I use, to do that, 2, 4, 6. So I use 6 electrons to do that. Okay. So I'm just going to keep track. You don't have to keep track unless it helps you. So what it means is I have 20 electrons remaining. Now in the previous example, I had none remaining, so I was done. But this one I have 20. And so if you go back, it says, use all the remaining electrons to fill the octets with lone pairs. So we're going to add lone pairs, and we're going to start with the periphery. So the chlorine, like each chlorine, this is 2, right? So that's 2, 4, 6, 8. This is 2, and so I add 4, 6, 8. This is 2. Then I add 4, 6, 8. Okay, so now I personally count how many did I use to do that? Because I started with the periphery. I got everybody up to 8. On the previous example, there were none left, but it also had hydrogen. I would never add a lone pair to hydrogen. It only gets a single bond. All right, so if I count these up, it's 2, 4, 6, 8, 10, 12, 14, 16, 18. So I put on 18 dots, and I'm going to erase some of that green. I can't erase it all, but okay, so I added 18 dots. So 18 electrons. So I still have 2 left. Now, I can't put any more on the chlorine, so if you have any left over after you did the periphery, they go on the middle. So now I have 0. So I just used my 2, so now I'm up to 0 electrons. I used them all. And you can double count. So just count across. If I counted, I used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 electrons. And that's my magic number, 26. Okay, so I used 26 electrons. And now let's make sure everybody has 8. I'm going to erase. Sorry, I have to erase the blue there, but I do, so I can count. So if I look at my chlorine, they should all have 8. That's what I made them do. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay, they all have 8. And then I look at my nitrogen. Let's see. It has 2, 4, 6, 8. So everybody has 8. So this would be my structure. So let's take kind of a big picture view again and review what we did. We started with the molecular formula. Nitrogen was the first element, so we placed it in the center and then the other chlorine around it. We added up the valence electrons using the periodic table and got a total of 26. So the first thing we do is we place single bonds between the periphery atoms and the central atom. Okay. So we did that, and that used up 6 of my 26 electrons. So I had 20 electrons remaining. So then I have to place those 20 electrons onto my Lewis structure, and I start with the atoms on the outside, and I give them enough lone pairs so they have 8. So if it's not hydrogen, they all had a single bond, that would mean they would each get 3 lone pairs, because that would represent 8 electrons. So I did that to all the chlorine, and I counted up. That used 18 of my remaining electrons, so I still had electrons left over, and any electrons you have left over, you put onto the central atom, and so I put it on nitrogen. So now I had used all my electrons. Now before I called that a good structure, I went through and I made sure, one, I used 26 electrons. That was the magic number of electrons. 2, I made sure all the periphery atoms had 8 and the central atom had 8. Once I verified that, I finally said, okay, this structure is done. All right, so that is another Lewis structure. So now let's add a twist. The first 2 had single bonds, but we know that there can be double and triple bonds. So let's add that twist. So there's another step if you have multiple bonds. So you'll still do all the steps that we have done in the previous one, and then you'll add an extra step. So what's going to happen and how you know is if your central atom does not have enough electrons, okay? And that's when we go to step 4. Now, I said enough electrons, but I should be more specific. 8. So in this situation, you have placed all the electrons. The outside has 8. They get done first. And then you look at the center and it has 6 or it has 4. It doesn't have 8. That's when you know you need to do step 4. That's when you know you have a multiple bond. So what we're going to do is we are going to convert a lone pair into a bonding pair. I'll say it again. We're going to take a lone pair off the periphery atom and change it into a shared pair or a bonding pair. Every time we do that, we create a multiple bond. We don't add or take away from the electrons. We're just moving electrons. Okay, and here's an example of a double. They have, in the slide, it has a picture of something with double and a triple bond. That's what they're going to look like. All right, so let's try an example. And I'm thinking of an example. Okay. No, I don't want that. Sorry. That would not be an example. It was an S I wanted, but not. Okay, so let's do SO2. All right, so, and we're going to follow the octet rule. So let's just start. You know that this is going to have a double or triple bond, but only because I told you, right? So you didn't know that. So we would start as normal. We'd look, this is the first element, so that's going to go in the middle, and I'm going to put the other elements on the outside. So that's the first step. The second step is the valence electrons, which I'm going to have to go back to the other. So I have sulfur and I have oxygen. Let's go back to the other slide. So sulfur and oxygen are both in group 6. So they both have 6 valence electrons. So I have one sulfur and it will have 6 electrons. And then I have 2 oxygen atoms, and they will both have 6. They're both in the same group, so that's 12. So this is going to have 18 electrons. All right. So then what I do is I add single bonds. Always do that first. Add your single bonds. That is 2, 4 electrons. So this is my total. And you don't have to write all this. I'm just trying to get you to think through it. That's 4 electrons that I used because it's 2 single bonds. So that is what, 14 electrons are remaining. So with any remaining electrons, now first you're going to put it on the periphery, on the outside. Always do that first to make them have 8. So if you have a single bond, which both of these do, it's going to take 3 pairs to make 8. So there's 2. So now that oxygen has 8 around it, and now the same thing on the other side. Now to do that, I use 2, 4, 6, 8, 10, 12. 12 electrons. Whoops, I didn't change back to my marker. Oh, sorry, I touched something in it. There we go. My iPad had an update now, and if I just touch something, it moves around, and I apologize. Okay, so I used 12 for that, and so I still have 2 electrons left. And do you remember, if you fill the outside with their 8, anything left over after that goes on to the middle. Okay, so now at this point, I'd be like, okay, I used everything up. And so there's several things you need to check now. One is, did I really use 18 electrons? So 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so on my structure, I have the number 18, which is all I can use. I cannot add or remove now. It would automatically make it wrong. So I've got that. And then I want to check to see if everybody has 8. So the first oxygen on the left, 2, 4, 6, 8. That one's good. The one on the right, 2, 4, 6, 8. Yeah, because I make the periphery have 8, right? Now the sulfur, 2, 4, 6. It doesn't have 8. Now, if we were in class together, I'd say, okay, I'll solve that, and I would just do that. Now it has 8. Then I'd say, why can't I do that? That would be wrong. And hopefully you would say, yeah, because you have only 18 electrons. And if you just randomly add another pair, now I have 20. I don't have 20 electrons, so I can't just add a pair. Okay, this is how you know you have a multiple bond. You've added all the electrons you have, but your central atom doesn't have enough. So you're going to take one of the electrons on one of the oxygens, and it doesn't matter which side. It would be equal. So I'm going to take one of them off, and I'm going to take it away. So I could take it away. I'll erase it in a second. And then I'm going to redraw it as a double bond. So maybe another way to write that is I'm going to take it away, and it wouldn't matter which one I would choose, and I'm going to redraw it as a double bond. So now it would look like this. Now look what that did. Okay, oxygen still has 8, 2, 4, 6, 8. So I didn't upset that oxygen. But now sulfur has 2, 4, 6, 8. So now sulfur has 8. I didn't add any electrons, so I didn't go over 18. I just moved it. The other oxygen still has 8 because I did not change it. And so that is how I figure out that I have a multiple bond. So let's do another one. Okay, so now I would like to do, let me see, I'm trying to think in my mind what I want to do. Okay, let's do HCN. All right, so I'm going to do HCN. So the first thing, remember, we have to find the central atom. So I've been going to the first element, but hydrogen can't be in the middle. So if you go, the first element is hydrogen, go to carbon. So this means carbon's in the middle, and the hydrogen and nitrogen are on the outside of carbon. So this is kind of an interesting one in that how it looks on the molecular formula is how I'm going to line them up on the Lewis structure. Sometimes that happens, okay? But again, the reason hydrogen's not in the middle is because hydrogen can only have single bonds. So if hydrogen is first in the molecular formula, go to the next element and put that one in the middle. Now I'm going to add up the valence electrons. And so I have a hydrogen, which is here with a 1. So I have one hydrogen with 1 electron. Carbon has 4. I have 1 carbon with 4 electrons. And nitrogen next to it has 5. I have 1 nitrogen with 5 electrons. So that is what, 10 electrons total. So that's how many electrons, my magic number of electrons I can use, 10. So we start with that number and we add single bonds. Okay, so if I do that, I used 4 electrons for the bonds. And now I have 6 electrons remaining. So with the electrons remaining, you're going to place them as lone pairs onto the Lewis structure, starting with the periphery atoms. So if I started with, okay, so I see first, sorry, I jumped around there. Hydrogen is not going to have any lone pairs. And I might just put that in red. I see it all the time, but I don't want to see it all the time. Okay, it can only have a single bond, so that one's done. That's a good one. So I have 6 electrons, and so I place them on nitrogen. Okay, so now I have 0. I don't have any even to place on the carbon. Okay, so I know there's something going on here. So then I just do a couple double checks, and when you're doing it on your own, you do it kind of in your mind. It doesn't take as long, but I would make sure I use 10 electrons. I want 10 electrons on my structure. So 2, 4, 6, 8, 10. Okay, so I've got 10 electrons. And then the next thing I want to do is make sure that I treat elements like people. Sometimes I think about them that way, but that elements each have 8. Well, hydrogen's good with just 2. That one's good. And this nitrogen has 2, 4, 6, 8. Nitrogen's good. And then carbon only has 2, 4. Yeet. Okay, so what we know is that's your clue. That's how you know there's multiple bonds. If your central atom, after you've added all of the electrons, does not have 8, you fix that by shifting electrons and making a multiple bond. Okay, I can't shift any electrons on hydrogen. It can only have a single bond. So I'm going to take the electrons and move them. So the first one I'm going to move is this one here. It wouldn't matter which one you move. I just have to move them off nitrogen. So let me see. I'm going to erase what I just wrote, and I'm going to use my eraser. I've got to make my eraser smaller, though, so I don't erase my whole picture. Okay, so I'm going to erase this one. And I'm going to redraw it as a double bond. Now notice that keeps nitrogen at 2, 4, 6, 8. And it helps out carbon, but we're not all the way there. Carbon now has 2, 4, 6. So I have to do it again. So I'm going to take another one off nitrogen, and it wouldn't matter. I could take either 2. It doesn't matter. I'm going to erase it, and I'm going to redraw it as a triple bond. And so now I double check my nitrogen. It has 2, 4, 6, 8. So nitrogen still is okay. And now carbon has 2, 4, 6, 8. And so now carbon also has 8. And if you want to verify, I still only use 10, 2, 4, 6, 8, 10. So now what I've done is I've taken 10 electrons, the valence electrons, and I have placed them on this structure so that it fulfills the octet rule. And so that would be the Lewis structure for HCN. Now I have one more thing to add to all this Lewis structure, and I do have some other videos in our Canvas module, which these might be some of the same examples, but it could also have other examples that you can look at if you want to go over some more examples. You can also look in your textbook or even on YouTube. Now remember, we're using central atoms that follow the octet rule. So you could get introduced to ones that have expanded or more than 8 or fewer than 8 on the central atom, which is perfectly fine. It's just not what we're focusing and getting good at in our introductory class. The other thing, on YouTube, there could be people that, like, this isn't the only way to approach Lewis structures, so there's different ways to approach them. I encourage you to learn this way because it will help you in the event that you come across an exception. So I encourage this way, but it's not the only way to do Lewis structures. Lewis structures are like a puzzle, So we have something called a resonance structure, and in this process, I want to introduce the idea of what happens to a Lewis structure when there's a charge involved. So resonance structures are simply more than one structure that fits all the rules for a particular molecule. So sometimes there's really only one way to draw it, but sometimes, and we'll do an example, you might see that there could be more than one way to draw it. Now in our class, I won't ask you to have something with a resonance structure to draw all of the different structures, but I do want you to recognize sometimes you'll have a choice and you can write one way or another. In the next level chemistry, you'll learn something called oxidation numbers, and you'll learn how to figure out which resonance structure would be more likely. For us, I just want you to recognize that they exist. So here's an example. It's CO3, 2 negative. And so we're going to, I see there's a charge there, but we're going to approach it just like we would any other Lewis structure. That means the first one is going to go in the middle, and I'm going to draw 3 oxygens around the outside. And now I'm going to look at the periodic table and add up my valence electrons. And I think I put one on the last page. Yeah, here we are. So I have carbon, remember these numbers, which is 4. And I have oxygen, which is 6. Okay, so carbon, I have 1 of them. Oxygen, I have 3 of them. So 3 times 6 is 18. So I add those together and I get 22. So that's what we've been doing so far. Now, what this one has that the others have not is this 2 negative. So it has a charge. So what do you do when there's a charge? Well, we think about what does a charge mean. And if you recall, a negative charge means electrons were added. If you gain electrons, you get a negative charge. So in this particular situation, 2 electrons were added to this for stability. That's how it has to exist with 2 extra electrons. So we have to add those 2 electrons. Okay, so that is what you do when you have a charge. This is for the negative charge. Now, if we were in class, I would say, what would you do if it was a positive charge? So think about it. Okay, so positive charge means you've lost electrons. So if you had a structure like this, but instead of a 2 negative, it had a positive, then you would have to subtract electrons from the total. Okay, so a negative charge, you add electrons to the total. A positive charge, you subtract electrons from the total. Okay, so negative charge, add the number of electrons because electrons are negative, right? Positive charge, you subtract electrons from your total. Okay, so now this is our total, 24. So we're going to now everything's the same as we've been doing. Like that's the only difference if you see a charge. So single bonds, 2, 4, 6. Okay, so I use 6 electrons, which gives me what, 18? I'm going to take the 18 and add 8. So that means all the oxygens, if they already have a single bond, they need 3 lone pairs. That will give them all 8. So how I used 18, right? 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so I only had 18 remaining, and I used them all to fill the outside ones, which is where you always start. So I have no more to put on the central atom. So at this point, and you just after a few examples, you may be able to start seeing what's going on. But if you didn't, there's a couple things you need to check before you give up and say this one's done. One would be to count and make sure we have 24 electrons. That was our total, the magic number of electrons: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I used 24 electrons. I find I can't count by 2 when I'm trying to. Okay, so I did use 24. Then I make sure everybody has 8. Well, all the oxygens, 2, 4, 6, 8. All the oxygens have 8. I made them that way. So they're all good. And then the carbon, though, it only has 6. I can't add any more electrons. I used the total 24. So I can't just add electrons. And so what do you do when your central atom does not have enough electrons, but you've used your total? That's right. You make a multiple bond. Now here's where the idea of resonance comes in. I can take one of the lone pairs or non-bonding pairs off of any of the oxygens, and I would get an equivalent thing. So that's the resonance. I could have a double bond between any of the oxygens. So there's more than one way I could write it as a Lewis structure. Now these would all be equal to each other. Sometimes resonance structures are not equal to each other. There's more than one way. They'll actually look different from each other in terms of where the bonds are. Like the doubles or whatever. So, but in this case, they would all be equal. So I'm going to take one. I think I'm just going to take it off the oxygen on the left. Doesn't matter which one I remove, and I'm going to redraw it. And so with that double bond, I fixed that oxygen still sees 8, and now carbon sees 8. Now, one thing you will notice with Lewis structures with a charge, it's very common, and I would expect it, to draw a bracket around the structure and then put the charge on the outside. The reason this is important is about how we're communicating to other people, what we're doing, and what it tells someone looking at your Lewis structure is that 2 electrons were added to that structure. So it's actually CO3 to negative, not CO3, which would only have 22 electrons. Okay, so it's an important part of completing anything with a charge that you put the brackets and then put whatever the charge is outside the brackets. All right, so that gives you an idea and some examples to start practicing Lewis structures. Please feel free always to ask questions or to let me know if you're struggling with it, and so we can work on it a little bit more.